All right, so we're plugging in a 2, so that would be 2 squared plus 1, which would be 4 plus 1, which would be 5, right? We get f of x equals 5. So our input was 2 and our output was 5. Everybody understand how functions work? That's not new to us. All right, awesome. All right, now we do have to get into, in 1010 we just do really surface level stuff. We do have to actually talk like official definitions in 1050. So here is the official definition of a function. It says a function f is a rule that assigns to each element x in a set A exactly one and only one element in a set B, which we call f of x. Now that's a fancy way of saying, isn't it true that for each input there should only be one output? That's by definition, each x should only have one y. That's by definition what makes something a function. So we have this set A, and we have a set B here, and we have, starting with our input of x, we plug it into the function, we get out a y value, or f of x is how we write y in 1050. So this would be an example of a function. This x only had one y. Do you guys see? Alright, same with here, plug in A, we will get f of A. Each x value or each input should only have one output. So that's just a fancy way of saying that. Now that also means it would pass a function, by definition, would pass the vertical line test. So let me draw something and ask you, would this quadratic be a function by definition? Yeah, it passes the vertical line test. We can draw a bunch of vertical lines and it never crosses the line twice in one spot. Now if I change it and I have a function that looks like this, it is now considered not a function because it doesn't pass the vertical line test. At that x value there are two y values, right everybody? Not a function. Awesome, so let's just get into the math of it then. This will be like the homework, so we'll get right into it. It says, analyzing a function. So given f of x is equal to x squared plus 4, it says, describe in words how f acts on the input of x to produce the output of f of x. So this is saying in words, what are we doing to get an answer? Well, aren't we squaring something and then adding 4? That's in words what we're doing, right? To get our output. So you would literally just write square, then add 4. Easy, right, everyone? All right, well, now it says evaluate f of negative 2. So we're taking negative 2, we're squaring it, and then adding 4. So we would do negative 2 squared and then add 4. So isn't that 4 plus 4, which is 8. So our input was negative 2, our output was 8. Okay, awesome. Now it says find the domain and range of the function f of x. Now this is why in 1010 we spent so much time getting really good and familiar with shifting of graphs. Because if you have a rough sketch of a graph of what this looks like, domain and range is easy. So just a reminder, this is a quadratic, that's a U shape, that's by definition something squared, and it's shifted what? 4 what? 4 up. Up 4, right everybody? So a rough sketch of that would look like this, would it not? Okay, well then the domain's easy. Where's the domain? What's our input? Where's it growing from left to right? Yep, negative infinity to infinity. We can plug in anything to a quadratic. So all real numbers or negative infinity to infinity. Our range, if you have a rough sketch, is really easy. It is 4 to infinity. Good. Alright, now this next part is just a fancy way of drawing this exact same thing, how a function works. It says, and that's supposed to say machine, I don't know why I put a T in there. Draw a machine diagram for the function for part B. So it's saying, what are we doing here? Basically, like, weren't we plugging in a 2 and getting out an 8? So what they do is they go, okay, we take negative 2, we plug it into a machine. The machine was, we square it, then add 4. Square, then add 4. I'm getting lazy there. We square, then add 4, and then we spit out a 8. That's how they want you to draw a machine diagram. Now they draw all like fancy, like, so now it says draw one in general. They like make their machine all fancy, like they go like this. Alright, it's going to go in this little hole and then spit out here. So like, we plug in general, don't we plug in x? And then it comes and it gets calculated x squared plus 4, agreed? And it spits out a y value or an f of x value. There's the general machine. They just draw the machine fancier. I don't care. If you have arrows pointing, that's all I care about. All good? It doesn't matter. Either one will work. Words or equation is great. example, same idea. I'm asking you, my computer has had a hard time today. All right, describe in words how f acts on the input of x to produce the output f of x. Tell me what we're doing to get an answer. Subtracting 2 then. So we would just write that. Subtract 2. Then, after that, we divide by 3. All right. Now evaluate f of negative 2. We would plug in a negative 2, wouldn't we? So what would that be? Negative 2 minus 2, people. Negative 4/3, right? That would be our answer. Awesome. Now it says find the domain and range of the function f of x. Now I want to remind you, as long as we split this up and divide it out correctly, it's okay to split it up. Isn't that the same thing as 1/3 x minus 2/3? Yes? Same thing, as long as you divide both pieces. Well, that's a degree 1. That means it's linear. Well, a line looks like this. Well, if that's true, then the domain and range of a line is all real numbers, isn't it? Pointing left and right, up and down forever. Okay, awesome. Okay, awesome. Now it says draw a machine diagram. Do we get the picture with the machine diagram? Okay, yes.
On part A, could we not have said divide by 3 then? Would it be wrong?
Great question. So if you said divide by 3 then subtract 2, this is what it would have looked like. Divide by 3 then subtract 2. Do you see how order does matter?
Yeah.
Because then you'd have to divide by 3 first, then subtract 2. So with this one, to calculate it, wouldn't you need to subtract 2 first and then divide by 3?
Yeah.
If I plugged in anything. So yeah, order does matter in how you say it. Great question. Alrighty, let's keep going forward here. Alright, so now it says evaluate the function. Now, super easy stuff. If it says f of 1, we know we plug in a 1, so we have negative 2 times 1 squared plus 1 minus 3. Notice I used parentheses and replaced x with a 1. Calculating correctly, negative 2 does not go in. We know that it shouldn't go in. Isn't that negative 2 times by 1 squared is 1? So we have negative 2 times 1 plus 1 minus 3. Well, then that's negative 2 plus 1 minus 3. And then you would just add straight over. Negative 2 plus 1 is negative 1. Negative 1 minus 3 is negative 4. So my answer, f of 1 is negative 4. All good. So what do you think I'd do if I said find f of negative a? Yep, plug in negative a for x. You're right. So we have negative 2, and instead of an x, I have negative a squared. And then I have a plus, and then I have negative a minus 3. Now simplify it. So negative 2 would not go in. We know that. But isn't negative a squared a positive a squared? So we have negative 2 positive a squared. Does everybody understand that? Then we have a plus and negative, so that's minus a minus 3. And that would be your simplified answer. All right, so let's now do some more advanced algebra here. This is where people start to freak out for some reason, but we shouldn't. If I said find f of a plus h, what do you think you do with the a plus h? Plug it in for x. So let's write this out. We have a negative 2. This is where I would start taking notes for these two, because this is where advanced algebra comes in. So we have negative 2, and instead of x, we have now an a plus h squared, plus, instead of an x, we have an a plus h. Notice anytime I substitute something in, I use parentheses. And now it's asking us to simplify it. So that means put it in standard form. Now we're going to be very careful, because we're not going to break the forbidden rule and square that, because that's not how you do that. We know that's negative 2 times a plus h times a plus h. Do you agree? And then, so let's just focus on this part, simplifying this part first. When multiplying 3 things together, you always multiply 2 together and then multiply in the third thing. So I'm going to multiply these two things together first. A times a is a squared. A times h is plus ah. Now we have an h times a, so that's ha or ah, I'll stay consistent. And then h times h is h squared. So combine like terms, so that would be a squared, and then how many ah's? 2 ah's. 1 apple plus 1 apple is 2 apples. The apple doesn't change. So we have 2 ah's plus h squared. Now all I've done is multiply out that. So don't I need to times all that stuff to negative 2? Yeah. Alright, so continuing simplifying this correctly. Negative 2 times a squared is negative 2a squared. Negative 2 times positive 2ah is negative 4ah. Negative 2 times positive h squared is negative 2h squared. Do you agree? And now I have done that part. Then we have plus a plus h Since that wasn't a negative, we didn't need to distribute any negatives, and then minus 3. Now looking at this answer, combine all like terms. Are there any like terms? Nope, so we're done. Standard form means highest degree to lowest degree. Notice degree 2. This is 1 and 1, which added to be 2. So degree 2, degree 2, degree 2, degree 1, constant. It's in standard form. And the degree 2s you could switch around. It doesn't matter. Questions on that? Now, okay, if that doesn't freak you out, the next piece should not freak you out. And this is where people freeze. Right here. Boom. They freeze. So if I said find f of a plus h, didn't we just do that? But then it says then take and subtract f of a. So what do you think we're going to do with that? Subtract f of a. So we would take and plug in an a and then subtract that f of a off. Does everybody see? And then after that we'll divide by h. So we're literally going to say, okay, now we're going to subtract f of a. So we're taking this, subtracting f of a. To find f of a, that means plug in an a wherever there's an x. So won't we be subtracting, with subtraction you need parentheses, we'll be subtracting, plugging in an a. This wouldn't that become that? So that would be negative 2a squared plus a minus 3. So it's saying take this function and subtract off f of a. So I'm going to distribute my negative through. So that'll become plus 2a squared minus a plus 3. You guys see how I distributed the negative? Alright, so now I can forget that. It says take f of a plus h and subtract off f of a. So combine like terms. 2a squared, 2a squared. Don't those go away. Alright, now we have a minus 4ah. Do you have any other ah's? So we have minus 4ah. Notice I cross it out as I go. Negative 2h squared. Any other h squareds? This is a bad thing you should probably move. So minus 2h squared. And then we have plus a minus a, don't we? So that's gone. Plus h. No other h's. And then we have minus 3 plus 3. So isn't that our top? Now that's our answer, but we still then have to divide by h. Now we know it would be really bad to just say, oh, my h's divide out, isn't it? We can't divide across addition signs. However, isn't it appropriate if all of the top divides by h that we could divide out an h? Yes. If each piece of the top divides by h, then it would be appropriate to divide out the h. So notice, once it stops going crazy, alright, so they all divide by h. This becomes a 1, this h is gone, h squared and h divide out to become a h, and then h and h divide out to become a 1. So my final answer is negative 4a, my h is gone, minus 2h, true, and then plus 1. All divided by 1, and I don't need to write that. So look, it simplified to be something really nice and pretty. Just a really advanced algebra, guys. That is calculus level algebra, but it wasn't that bad. You just got to be careful. Okay, I need you to do one by yourself now. So what I need you to do is try these by yourself. So given f of x is equal to x squared minus x, find f of a plus h. I've already written the answer. That's not the point. You got to make sure you can do it. If you can't, you got to ask me for help. Then, once you've got the top one right, move on to the bottom and simplify it down. You should get this. If you can't get it, don't just say, okay, I can't get it. Ask me what you're not understanding. Ready? Go. You are going to have plenty of time to work on homework. Please do this to make sure you're good with our algebra before we move forward. Way overthinking this. If I said find f of a plus h, what do? Plug in a plus h. Haven't we done that there? So f of a plus h is a squared plus 2ah plus h squared minus a minus h. Do you all agree? Moving on. Subtract. What is f of a, everybody? The function when you plug in a is a squared minus a. Do you agree? So we're subtracting a squared minus a. But don't I need to distribute the negative? Do you see what I'm saying? Right. Subtract off f of a, which is a squared minus a. Does that make sense, everybody? So then that would become minus a squared, wouldn't it? Plus a. And now we can just ignore this stuff. So now combine like terms. What's left? A squareds cancel out. So you have 2ah, don't you? Plus h squared. Then a and minus a cancel out. And then we have a minus h. And that's the top simplified. Do we have questions on how I simplified the top? Then all divided by h. Divide each thing by h and you would get 2a plus h minus 1. Okay. turn off the light, and we'll keep moving forward. If I said to you, find the domain, you'd say, okay, domain is input, what I can plug into a function. Now remember, in 1010, we really focused on two functions that have restrictions. So restrictions come from when we have even roots. Here's why. If we were to graph something, we cannot graph imaginary numbers. On the real number line, imaginary numbers do not exist. So we had restrictions. So right here, we could not plug in a negative under a square root, correct? Well, if that's true, then where can we start? Can I plug in the 0? Square root of 0, 0. That's okay, correct? Yes. But we have to plug in 0 and forward because we can't plug in negatives. So how we did that is we said what's under a square root, so what is under our square root cannot be negative. So isn't it true to say x, what's underneath, needs to be greater than or equal to 0? And that's your domain. That's one way of writing the domain. We're going to write it in interval notation. So that in interval notation would say, starting at 0, we go to infinity. Because that's x is greater than or equal to 0. Easy stuff. Right. Okay. Moving on to this one's domain. You'd say, oh, I have a square root. Underneath the square root, x plus 2 needs to be greater than or equal to 0. Do you agree? Subtract 2. So x needs to be greater than or equal to negative 2. Starting at negative 2, forward. Do you guys see how that works? So you'd say from negative 2 to infinity would be our domain, including negative 2, because we can't have 0 underneath. Questions on that? So if you have a restriction, that's when your domain changes from all real numbers. If you don't have a restriction, then you can plug in anything, all real numbers. Okay, our second restriction came from when we had a rational function. Rational function is when there's a variable on the bottom. Why? Because we can't divide by 0. I promise you, if you were to graph anything that is rational, what's going to happen with your domain, with your graph, is it's going to go, 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 and anywhere that it makes the bottom 0, it's literally going to get to that value, jump over it, and continue. So everybody right here, what would my restriction be? Our denominator can't be 0, so x can't be 0, but it can be anything but 0, correct? So picture yourself connecting your domain through. It can be anything, it gets to 0, jumps over, and then goes to infinity. Do you guys see? So our domain in interval notation would be negative infinity up to 0, then it jumps over 0, so not including 0, union, and then it continues onward. Then from 0 to infinity would be your domain. Questions on that? Pretty easy? Can the top be 0? Yes. Okay, good. So right here, let's say the domain. If we have x plus 1 over x minus 1, the restriction is x cannot be 1. Okay, good. X cannot be 1. So let's write the domain in interval notation. It's coming in from negative infinity. Once it gets to 1, it jumps over it, doesn't it? Union, then from 1 to infinity, continues onward. It can be anything but 1. Alright, so now we're going to be doing just extremely advanced domains. So right here, what is the domain of x squared plus 1? Negative infinity to infinity. Guys, quadratics don't have restrictions. Do you see a fraction? No. Do you see a square root? No. So there are no restrictions. Therefore, the domain is all real numbers. Are we good? Yep. All right, moving on. The restriction is x cannot be 4. So you'd write negative infinity up to 4. Jumps over, union, 4 to infinity. All good? All right, right here, our domain is what? Negative 1 to infinity. Do you guys see how to do the algebra? Set what's underneath. X plus 1 needs to be greater than or equal to 0. Subtract 1. All good. Yes? No? Yes? No? Okay, x cubed plus 2x plus 3. Do you see a problem? Do you see any restrictions necessary? No. So what's the domain? All real numbers. There's no problems. We can plug in anything. Correct. Alright, what would be the restriction here? Our true statement would be, isn't it true that 3x minus 1 needs to be greater than or equal to 0? Add 1, divide by 3. X needs to be greater than or equal to 1/3. Well, if that's true, your domain will be 1/3 to infinity. Alright, right here, don't my x plus 1's divide out? Technically, yes, but don't we restrict before we divide? Yes, so our restriction is x cannot be negative 1. Do you agree? Well, what about the 3?
Doesn't matter.
It doesn't matter. There's no variable there. Way to remember, guys. So you have negative infinity up to negative 1. It jumps over, union, negative 1 to infinity. You guys are doing great. Okay, this is the first time I need you to actually take notes because you're going to have forgotten this. We did learn it in 1050, but it's been a while. I mean, 1010, but it's been a while. Alright, so find the domain of the square root of x squared plus x minus 2. So starting out, you know your true statement. Isn't it true, just like with all the others, you'd say our x squared plus x minus 2 has to be greater than or equal to 0. Now, solving a quadratic inequality is different than linear. Linear, you can just solve for x. But with quadratic, what we have to do is we have to find the zeros and then test on a number line to find our domain. So let's find the zeros. To find the zeros, we would factor this. What multiplies to be -2 and adds up to be 1. 1 times 2, -1, +2. I can quick factor because my leading coefficient is +1. So this quick factors to be x minus 1 and x plus 2. So if that's true, then our zeros are 1 and -2. So to find the domain for a quadratic inequality, you have to test it on a number line. So I created my number line, and it's either going to be yes, no, yes, no, yes, no. It always bounces. Does everybody agree? Yes. All right, well, let's plug in a value then. The easiest value to see if it's a true statement. Isn't it the easiest one to plug in is 0? Yeah. Okay, let's plug in 0, and if this is yes, then these are no's, and vice versa. So let's plug in a 0 right here and see if it's a true statement. That's 0 squared plus 0 minus 2 is greater than or equal to 0. Is -2 greater than or equal to 0? No. So that's not a true statement, so that is not in our domain. Well, if that's a no, then these are yeses. It always bounces. So wherever there's a yes is the answer. That's your domain. So aren't we coming in from -infinity up to -2? Not including or including -2. It can be 0 in this one, can't it? So including -2, union, and then from 1 to infinity. That's where the yeses were. So that's our domain for this one. Are we good with that? All right, so the next one has a couple things here. Now, this is how I recommend doing it. Splitting it up, and if there's more than one restriction, split it up and then just put your answer together. So looking at this one, we have two potential problems. Isn't it true that the bottom can't be 0? Yeah. So I write down that first. X cannot be 0. That takes care of that one. But now we also have a square root. So my second true statement is not the square root, but what's under the square root, 1 minus x needs to be greater than or equal to 0. Do you guys see how that's our second true statement? Now we're going to solve for each, find the domains, and then we'll just merge them together. So x can't be 0. That one's domain. Great. Let's solve for x. Subtract 1. So we have -x is greater than or equal to -1. I subtracted 1. Are we good? Yep. Divide both sides by a negative. Way to remember. If you divide an inequality by a negative, you got to flip the sign. So x value is less than or equal to 1. Now look, if I were to draw that out, x value is below 1. That would be -infinity up to 1. And that would be including like this. So picture yourself, you're coming in from -infinity up to 1, right? Well, it says it can't be 0. Well, isn't 0 right here? We're going to cross through 0. So what's going to happen? It's going to come in from -infinity, and once it hits 0, it's going to jump over it. Because it can't be 0, as everybody sees. So we're going to come in from -infinity. Once it gets to 0, it's got to jump over it. So from -infinity up to 0, it jumps over. And then from 0 to 1 is in our domain, but not including 0. Does everybody see how that would connect it through? It's just jumping over the 0. So then from 0 up to 1. Now 1 gets included. 1 can be in the domain. 0 can't, so that's why there's parentheses. So that's a union. So I just merge them together. I just think about connecting it through. Are you kind of good? Okay. Advanced domains. Let's do a couple more advanced domains. We're getting actually pretty close to being done with the lesson. Alright, so let's do these two. So looking at the top one, x squared divided by the square root of 1 minus x, on top, is there a restriction? No. But there are still two restrictions here. Isn't it true that the entire bottom cannot be 0? So my first true statement is the square root of 1 minus x cannot be 0. The entire bottom can't be 0. My second true statement, isn't it true that what's under the square root has to be greater than or equal to 0? So 1 minus x has to be greater than or equal to 0. Let's just solve these individually and merge them together. So solve for the x value that will make the bottom 0. So we solve for x. So we square both sides. So then we have 1 minus x, because root cancels out with power, cannot equal 0 squared is 0. Solving for x, subtract 1. Negative x cannot be -1, so x cannot be 1. Do you agree? X cannot be 1. That is the restriction. That one's domain. Let's do this one's domain. So solving for x, subtract 1. Negative x is greater than or equal to -1. Divide both sides by a negative, so x is less than or equal to 1. So look, if we were to write out this one in interval notation, we're coming in from negative infinity up to 1, like that, aren't we? But then it says x can't be 1. So what's the only change I need to make? Yep, instead of a bracket, it can't be 1. So we would just put a parenthesis. So our official domain is negative infinity up to 1. That would be merging them together. Okay. The cube root of x plus 3's domain is all real numbers. Yes. Can't we plug in negatives into odd roots? Yes, this is not an even root. That is not the same as an even root. If it was a fourth root, the restriction would be x values greater than or equal to negative 3, just like a square root, but it's an odd root. Odd roots can have positives and negatives underneath them. All right, this is why I don't have to go through these. It's up to you guys. Do you need to see a couple more advanced domains, or are you good? Yeah? Awesome. So what would I do? I won't go through it, but wouldn't I just factor the denominator and the restrictions are on bottom? Yeah? With this one, wouldn't my true statement be 9 minus x squared is greater than or equal to 0? Don't we solve quadratic inequalities by making the number line? Yes, no, yes. Right, everyone? And then here, my two true statements. Let's just see if you can set up the two true statements. One of them. T plus 1 is greater than or equal to 0. Second true statement. The whole bottom, correct? The square root of t plus 1 cannot be 0. And then you just solve merge. All good? Okay. All right. This is the last little piece here. Piecewise functions. Guys, piecewise function is just taking multiple functions and putting it onto one graph or into one function. So it says, okay, we have an entire function f of x, and we're taking pieces of a quadratic and pieces of a line. Now it says you're going to take the quadratic piece for any x values that are greater than or equal to 2. We're going to do the line, though, for all the x values that are less than 2. Does everybody see? So which one would I plug in? If I said find f of 4, you don't just plug it into both. No. 4 is greater than 2. Do you agree? So it would be plugged into the top one. Do you guys see? Because it says do the quadratic for any x that is greater than or equal to 2. So you'd plug it into the top one. So you'd be doing 4 squared plus 1, so that would be 17. F of negative 3, plug it into the top or bottom? Bottom, because negative 3 is less than 2. Negative 3 minus 3 is negative 6. That would be your answer. F of 2, do you plug it into the top or bottom? Top, because it says we're equal to 2. Do you guys see? So then it would be 2 squared is 4 plus 1 is 5. So now what if it has multiple pieces? Looking at this one, we have an x squared for x lies below 0. We have x minus 2 for x values between 0 and 3. And we have the square root of x for x values greater than or equal to 3. So just tell me which one you would plug negative 1 into. The first, the top. Does everybody see why? Negative 1 is less than 0. So then that would be negative 1 squared, which is 1. All right, f of 0, where would you plug it in? Middle. 0 minus 2 is negative 2. Good. And then f of 2, you plug into? It only fits one criteria. Middle. Isn't 2 between 0 and 3? So then 2 minus 2 is 0. All right, f of 3, you'd plug it in here, wouldn't you? So we get root 3. And then f of 4, you plug into the bottom one, because that is greater than 3. So the square root of 4 is 2. Pretty easy as long as you know what you're doing. Questions on that? All right, now I don't want to hear any sides when they see this. Yes? Great question. When simplifying, when solving, we need plus or minuses. When simplifying, no. Just go with the primary root. Great question. All right, so guys, we don't skip story problems. Look how easy it is. Read it. If an astronaut weighs 130 pounds on the surface of the Earth, then her weight when she is h miles above the Earth is given by the function w of h equals this. What is her weight when she is 100 miles above the Earth? Where are you going to plug in 100? To h. So is it hard just because it has words? No, so don't make it hard. Okay, ready? And that's the end of the lesson. The rest of the time you do. 2.1, you need to do odds because with our book, you only get odds. The answers are only the odd answers, interestingly enough. The answers are on the back of that worksheet.